Okay, enough for really great discoveries. Now let's talk about some simple observations on isothermal gas expansions. The purpose here is to look at a series of processes in which temperature is held constant. And we're going to calculate how much work we get from allowing a gas to expand under various conditions. And what we'll discover is that when we allow the gas to expand reversibly, we get the most work. This is neat. This is important. Okay, so we have constant temperature because it's isothermal. And let's do a series of experiments. First, let's set the external pressure equal to 0. So we have an experiment that looks like this. We have a piston. We have a pair of stops. We have another pair of stops. We start at P1, V1. And P external is equal to 0. In other words, this is vacuum. And so what happens when we remove these stops is that the piston slams up against the next pair of stops. It goes very fast. You could calculate the time. You could do all sorts of stuff. But what is important is that this piston, in moving from here to here, did no work on the surroundings because work is the integral of pressure dV, and the pressure external is 0. It doesn't matter what the pressure internal is. This is a point that is often confusing because you can think, well, maybe I could calculate what the internal pressure is even for this very rapid process. It doesn't matter. The thermodynamics is asking you, what work does this thing do on the surroundings, or the surroundings do on the system? And there is no work done on the surroundings because pressure is 0. So the work for this process is integral, or minus the integral, V1, V2, P dV. And it's P external, and P external is 0, so there's no work. Okay, the next example is, well, when this piston slams up against these stops, the gas has expanded. We're doing this isothermally, so this is in contact with a heat bath. The gas has expanded. It has a particular pressure and a particular volume. Every time you do the experiment in equilibrium with the heat bath at T, you will get the same P2 and V2.